Hello, welcome to my YouTube channel. This channel is based only for the students who are preparing for M.Sc level exam. First of all, we are going to study particle nature of wave. First, we saw about photoelectric effect, which is given by Albert Einstein, for which he got Nobel Prize for this invention. In photoelectric effect, electromagnetic wave of suitable wavelength or having some energy hits on a metal surface and electrons are ejected from that metal surface. This electron constitutes some current. These currents are called photocurrent and this ejected electron is called photoelectron. And these photoelectrons are moved with some energy which is given by this h mu minus h mu naught. This h mu naught is called work function and this h mu is the energy of the incident electromagnetic radiation. And here, what is work function? Minimum amount of energy required to eject a electron from the metal surface is called work function, below which we cannot eject a electron from that surface. If the electromagnetic radiation have energy less than this work function, then you cannot eject electron. This mu naught is called threshold frequency, the minimum frequency below which electron ejection is not possible. This is the diagram, and also we introduce another term, that is stopping potential. The stopping potential is there is written the minimum amount of energy potential which required to stop the moving electron which is ejected from the metal surface. This EBS is equal to maximum kinetic energy of the electron, and we got three formulas, and we will solve problem on this formula. Later, we first go to one problem. The kinetic energy of a photoelectron, Ke means kinetic energy of a photoelectron is given by 4 into 10 to the power minus 19 joule, and wavelength of light is given by 3000 angstrom. Then stopping potential. Find stopping potential. First of all, we have to think what is the formula. Then we are going to solve the problem. Kinetic energy is given by, here is the solution. The kinetic energy is in the form of joule. So we have to remember that when we deal with the problem on photoelectric effect, we have to convert it in electron volt. So we divided by a charge of electron so that it will convert it into electron volt, the energy in the form of electron volt, which is equal to, this kinetic energy is equal to EBS. We have seen the formula, then directly solve the problem. And we also go another formula question. Find the threshold wavelength of above problem. The problem which is given by in equation 1, we have asked to this question, we asked to find the threshold wavelength. Here is the solution of that question. EVS is equal to h mu minus h mu naught, and mu also we know c by lambda, where c is the velocity of light and lambda is the wavelength of light, and this mu naught, which is threshold frequency, gives threshold wavelength, c by threshold wavelength. And later we have to remember this formula, this value hc equal to 12.4 10 to the power 3 electron volt angstrom, and putting these all these values, we know we got the threshold wavelength which is given by 7590 angstrom. Here I am going to solve another question. This question are a previous year question of JAM. Question is, wavelength of photoelectric threshold material is 2300 angstrom. Find kinetic energy of electron ejected from the surface by light of wavelength 1800 Armstrong. First of all, we thought the formula which is based on the given question. Now we are going to solve the problem. Here is the solution written in this here. First, h mu naught, which is work function. This work function is equal to h mu naught, or previously we know that this mu naught is c by threshold wavelength, and which is the threshold wavelength is given by 23 Armstrong. And by putting all these values and we solve, we got work function. Directly we can put this value of Sc is 12.4 electron volt Armstrong. 12.4 into 10 to the power 3 electron volt Armstrong we can put here directly. And so by solving this, we can found work function is this 0.86 into 10 to the power minus 18 joule. The question asked for find kinetic energy, and we put the formula h mu minus h mu naught. This h mu naught is work function, and we put this mu is c by lambda. By putting all these values and solve to find the answer is given by 1.5 electron volt. We got answer 24 into 10 to the power minus 20 joule. By letters dividing the charge of electron, we got 1.5 electron volt, which is the answer asked by the question. Here another question. In photoelectric effect experiment, ultraviolet light of wavelength 320 nanometer falls on the photocathode with work function 2.1 electron volt. What is the stopping potential? This question is one of the previous year question of JAM exam. We put the answer. Kinetic energy is equal to h mu minus h mu naught. This h mu naught is work function which is given in the question, and this mu we convert c by lambda because this lambda is given. We have to find kinetic energy first, then later we equal this kinetic energy with stopping potential multiplied by with charge of electron, and we got the answer which is asked by the question. And putting these all the values and solving it, we got kinetic energy is equal to 1.78 electron volt. Later this kinetic energy is equal to the stopping potential multiplied by with the charge of electron, and solving this we got the answer 1.78 volt, which is stopping potential asked by the question. Thank you.